Here we go. So today we're going to be doing an extraction of some hops. I got some Fuggle hops from a local hop company here that sources all local Washington grown hops. So I'm going to open up this package of what are called Fuggle hops. F-U-G-G-L-E, Fuggle hops. So in this bag here is around 1 kilogram of hops, 1,000 grams. So I'm just going to open up one corner of this to help make this loading this easier into the system. Make a small hole there like that. And I've already got my top open over here. I'm just going to pick one of the columns. I'm just going to choose this end one, open it up, and begin to load some of these hops in here. Kind of breaking them up at the end as I go here so they easily come out. So some of you guys might be wondering what does this smell like on the other side of the camera? It smells a little funky. I don't know if I would call it that appealing. It smells a little kind of like some wet feet, to be honest. But you know, in beer brewing, they use all sorts of funky flavors and stuff when it comes to beer brewing. So I'm not surprised these are kind of fugly smelling. So I'm beginning to load these up, and as I go here, I'm going to stop occasionally, take a look, and I'm going to grab my hefty-duty sanitary packer, aka a 2x4 right now. Just going to kind of load some of these hops and compact them down towards the bottom of the filter. Make some more room. I'm just going to take this gasket off for a minute. All right, keep loading this. Now this tube should hold just a little bit more than maybe 1 kilo. But all we're going to load in here is 1 kilo. It's going to be almost to the top if we get finished here. So make sure you don't cut too big of a hole on the corner of your bag, otherwise you'll have hops everywhere. Ask me how I know. All right, we're getting towards the top here. So we're going to take another break. Grab our sanitary packer again. Come in here and push down everything. Don't be afraid to compress it pretty decent. You know, we're going to try and fit all this material in this one spool. You can compress it a little bit too much. That was the question behind the camera was, hey, can you compress it too much? Yeah, you can a little bit. But I like to just give it a little bit of oomph, a little bit of manpower behind it, not too much. The actual amount that I like to put in there, if you're gonna get technical with it, is 3.5 grams per square inch or so, maybe 3.75 grams per square inch. So if you go to Google and type volume of a cylinder, you'll be able to calculate radius and the height, do some fancy multiplication, division, all that stuff, and you'll come up with the cubic inches of a column like this, or a spool, and the cylinder. You'll be able to take that volume and then you'll be able to divide that by 3.75 and be able to find out how many, or multiply that by 3.75 and figure out how many grams you should be able to get in your column. So that's 3.5 to 3.75 grams per square inch. Just find out how many square inch and multiply by that. You should be able to get that in your column. So use that as a reference point as for your packing. You know, try to reach to the brim fully packed. If you're down here, it means you're probably packing a little bit too hard for the volume. If you can't put enough in, obviously you're not packing hard enough. Try to reach that happy medium, and then make sure you're just evenly packing all the way up the column. That way you don't get any channeling happening. It's a thing you can happen when especially when it's too tightly packed. You can get these channels to form where the solvent only wants to go down the path of least resistance because there's too much packed material, and it's just like, hey, I'll just skip by here and make a nice little channel. So try to get a good even pack. All right. Oops. Leave the top there. Looks like a little fabric or something in there. Manufacturing. From the farm it came from. So I'm looking at my bag. I still got, I don't know, a good 1/3 left. So I want to have at least 1/3 of my column or so. That's about what I get in here, the whole bag. So I got the room in there. Maybe a little bit more pack in here. Almost down to the bottom of the bag here, getting there. Some more packing. I'm giving it some real force, like I'm kind of lightly putting my body weight on this. Okay. Almost all the way in here. One more little pack. Now, sometimes you might want to grind this material up. We're still doing some testing with the hops. This is something new. It's a little experimental for us. So I'm gonna try grinding them up in the future to see if we get a better yield, better result. But for today's extraction, we're just using some raw hops straight out the bag. All right, look at that. There's our whole bag. And it's right up to the top here. So I'll give it one light little last pack here to finish off the top end. I could fit a little bit more in here for sure. I got a good 10 inches or so to the top of the column. Let's see. Oh no, I got more than that. I got about 14, maybe 16 inches. So that's maybe half full right now. All right, now that I've gotten all my material loaded, I'm gonna go ahead and clean off the top. Just make sure that my gaskets are clean. The seal area is clean. There's not much of stuff in there. A little bit of pollen's okay, it's not gonna hurt us. Then I'm gonna take my gasket and put it back on top. Put my top lid on here. Before I actually put my top lid on though, I'm gonna secure the hose because it's just a little bit easier to do it like that when it's free and less rigid. So that's on. I'm gonna take my clamps. Got my gasket already in place. Now my rule of thumb is always put the brass on the right hand side so that if you're right-handed, it's easy to tighten everything down on the right hand. Try and keep everything uniform. So get that one, that one. Then when I get one side on, I'll just spin the clamp around, not try to get around to the back side. Just do it right from the front here. And I'll position my clamps like everything else. You can see that all my clamps are running uniformly, even over here. That way when I come in here and tighten everything, it's right hand, right hand, right hand, right hand. Easily tighten, okay? Just kind of position this nicely. And I'm gonna grab my 16mm ratcheting wrench. Up as tight. I'm gonna make sure to tighten these both evenly on both sides. So I start hearing some squeaks. Now today I'm using Teflon or PTFE. They're really PTFE seals in here. And those take a little bit more force than some of the Viton rubber gaskets. So I'm gonna give it a little bit, a couple extra turns on each squeak just to make sure it seals up. Okay, it sounds good. Now I'm gonna tighten up my hose connection that I put on top with my wrench, because I only did it hand tight when I put it on there. So make sure to tighten that up nice. So there we go. Just gonna go through and make sure everything else is good. All right. Now that we've got our material packed inside of our column, actually I'm gonna check the bottom, because when I reassembled this, I don't know if I tighten these, so I'm gonna try this. That's good. That's good. Okay, so the next thing before we begin is we're gonna do safety check. We're gonna pressure check and vacuum check. So I got my air line over here. I got my air hose for this, and I got a little valve and hose set up for it. I'm gonna hook that up. What I'm gonna do is I'm going to check all my lines where I need to put my air into in order to pressurize the system. I want to pressurize my evaporation vessel, my column. So I'm just gonna open up this. We're good there. Close off this. Open, open, open. Now I'm adding air into the system. I'm going to pressure check this column as well as the evaporation vessel. I'm going to start slow in stages. So right now I'm just going to go to like 30 pressure, 30 pounds per square inch, 30 psi. And we're going to turn off our valve. We don't want to go shooting up in pressure before we find any leaks. So we're going to check for leaks in stages here. So we're at 30 psi. We're just going to listen for any hissing, any leaks around the gaskets that we just connected. I don't hear anything. I don't hear anything. I'm also looking at my gauges, of course, and there's nothing, no movement. So it looks like it's safe to continue on. We'll go up. In a second, you're probably going to hear the compressor turn on. So we're at 40. 50. Normally when we do this for an engineer or when we do it for final certification for a licensed facility, we'll take it to 100 psi. For today, we're just going to take it at 60 psi. It's plenty safe. We'll never see even that. We'll probably never see over 60 psi during the entire process. In fact, I'll tell you we won't. Unless there's excess nitrogen in the system, we will likely see no pressure even near that. So as long as we're holding near 60, we should be solid for today. So again, I'm listening for any sort of loud hisses. I do hear I did hear a hiss coming out of this tube because that valve is just barely cracked down there, so I just closed that. We're good. Now I'm just going to let this sit for a few minutes. So I'll cut the cameras here and we'll let it sit for like 5 minutes. And then we'll come back and I'll show you guys the vacuum step. And that'll be the step we'll take prior to extraction that is required. Every time you do an extraction, you should always check for pressure because we're going to have gases in here. And then we want to check for vacuum prior to extraction to remove all the oxygen and check our seals for contraction and no leaks inwards. So we'll get back to you guys in just a few minutes while this sits here under pressure. All right, so now that we've done the critical pressure test, we're going to do our next safety check, and that's the vacuum check. So I'm going to go ahead and disconnect our hose here. Take my wrench. course, always wear safety glasses in case there's any sort of pressure blow off. You don't want shooting in your eyes. I'm going to put my hose down for a second. I'm going to release the pressure here. So once we reset back to 0, which is essentially now, we'll close off the valve. I'm going to go ahead and hook up my vacuum, which I have already connected to the system down here. I'm going to flip it on and open up my valve to the system. And then what I'm going to do is I'm going to go over here and make sure that it's pulling a vacuum on all of the vessels that I'm going to be using today. So the evaporation vessel and this here column full of material. Looks like the valves are, the needle on the gauges are slowly moving down, so I know that we're pulling a vacuum slowly but surely here. This is going to take about 3 minutes or so. Depends on the vacuum pump, the size of CFM, the displacement that it has, how long this process is going to take. But once we reach a full vacuum, which is going to be 30 inches of mercury, you're going to want to make sure to leave it running for your vacuum pump. You want to leave it running for an extra couple minutes to make sure to pull out any of the last molecules of oxygen out of there. So now, while I wait for the vacuum to pull, I'm going to disconnect my original hose line that I was using for pressure testing. I'm going to set that on my workbench here. And then I'm going to connect it up to our pump here. Today we're going to be using a prototype Haskell pump. This is a prototype pump provided to us by them directly, and we've been testing it out for a little while now. We're really getting good performance out of it. Right now we're seeing a pound, actually it's about 1.12 pounds per minute on the recovery side of things. That's at 120 degree Fahrenheit. Somebody can quote that in the comments on Celsius conversion. But it's at about 120 degrees Fahrenheit evaporation temperature on the evaporation pot here that we're seeing 1.12 pounds per minute on this pump. So it's a really great pump. It's beaten out a couple TRS-21s, about 3 or more, maybe 4 TRS-21s in one. This pump, it's definitely more than the original EXT420 Haskell. I mean, just look at the size of this thing. It's like extremely beefy. So I'm gonna hook up my hose line, which might be a little difficult because there's 100 pounds of pressure behind it here. There we go. And that's gonna be the hose, the air line's gonna be what drives our pump. So it's all pneumatically driven. So now we got our recovery pump hooked up in line here. We got our vacuum pump pulling down a full vacuum, which looks like it's reached. Just gonna tuck this hose back a little bit. So the gauges are reading a full negative 30 inches of mercury. We're going to let it sit here, like I said, for just a little bit longer. Want to make sure to pull down any last micro molecule, any last speck of oxygen in the system. We want to remove it. The reason why is because oxygen and a combustible mixture like butane, which we're using today, when they're mixed together, all they need is a flammable or a heat source in order to ignite into a flame. So we're going to remove all the oxygen, and that will eliminate any sort of combustion potential. All right, I think that's safe to go ahead and turn off now. I'm gonna close my valve first, then turn off the pump, and there you go. We safely vacuumed down the system prior to extraction. Just like in the pressure stage, I'm gonna let this sit for like 5, 10, 15 minutes, maybe even longer. Especially when you first assemble your extraction unit and you just put all the seals together for the first time, you want to let it sit for at least 24 hours. For here, we're just going to let it sit for a few minutes because we've run this machine numerous times and know it seals up. So we're going to leave it here for, I don't know, 5 minutes, we'll say. Then we'll come back and we'll start beginning processes of the extraction. And while that does it, I'm going to go grab some dry ice. So stay tuned. All right, we're back in action here. We're ready to extract. System sat under vacuum here for, I don't know, 10 minutes, 15 minutes. And now what we're gonna do is we're gonna prep our heat exchanger, which is a coil that we offer on our website, opensourcesteel.com. And we're gonna take some dry ice pellets and we're gonna fill up around the heat exchanger. And you're gonna see some CO2 emit here. Watch this, this will be fun. Now, I'm pouring it slowly because there's also alcohol in here. And that was warm alcohol, and if I pour all that pellets of dry ice in there too quick, it would have just shot up like a shower everywhere. So poured it slowly to help it cool as I dump it in there. Man, that ate all that dry ice. Holy cow. All right. So now my heat exchanger's got all the dry ice on it. This is going to remove any of the heat, displace any of the heat from the system if there, when the recovery process happens. Because as we exchange the gas from this hot 120 degree Fahrenheit, somebody convert it to Celsius. I don't know it off the top of my head. 120 degree Fahrenheit evaporation chamber is going to go through that pump, and that pump is also going to generate some heat, and that heat needs to be cooled down before it goes back into the tank. That way we don't build up back pressure on the pump and make it difficult to recover the gas, and it'll condense all that hot vapors back into a liquid, which we can put right back into our storage tank. So everything we're going to use today is going to be recycled. All the gas, all the butane is going to be recycled right back through the system. So now that we have our heat exchanger set up, we're ready to operate. But one more step I need to tear my scale. So I have my solvent scale sitting right back here behind me. And before I do, I need to grab some batteries for that. So I'm going to grab some batteries, plug in my scale, tear it out, and then we'll run. I'll be right back. So I got my scale over here. I turned it on and teared it out. So I'm going to be able to monitor all of the solvent that I'm dumping into the column. I get to know exactly how much I'm using today. So I'm just going to set this right back on here. Actually, I'll hang it. See if I can do this. Just hang it right here. Boom, you dig? Then we'll tear it out again. Now we're ready to run. Got our liquid flowing up to the top here. And we're ready to start the extraction process. So I'm going to set my tools down. That's why it's always nice to have your tools nearby, because there could be a leak and you need to tighten it real quick. So we had it close. Okay, so our liquid is currently sitting at the top of our column, ready to be dumped over our material. But like I said, we want to open this valve slowly. We don't want to just crack it wide open and let everything flow, because the change in pressure could actually rip your paper, your filter papers that are at the bottom. So we don't want to try and create too much of a differential in pressure. So we're going to slowly open the valve and then we'll fully open it. So as I do it, you're going to hear the sound of rushing solvent. There we go. I hear it coming in my system over here. And as I'm watching it, I'm going to watch the scale over here. I'm going to start the recovery process to help pull. Into these coils. So we're at 5 pounds. I'm only going to do 10 pounds of solvent. So we're at 7. 8. 9. 10. Exactly 10 pounds. I got it right on the dot. Now I'm going to come over here and check inside my collection vessel, see if there's any liquid flowing through yet, which there is. So right now I got solvent flowing through the system. So just jumping right now, just flowing through. as it's going, you can see the heat exchanger down here. It's giving off the gases because there's heat exchange going on. Those hot gases are coming out of that pump, being pumped right through that coil, and then back into our starting tank. Now, if I look at the recovery hose, it's actually starting to get cold and frosted over, starting to freeze the condensation in the air around the hose. So as this goes on, it's going to get nice and frosted over. So that's the heat exchanger doing all the work here. The heat exchanger is taking those hot gases and turning them back into a cold liquid. Really cold liquid. Let's take a look again inside our vessel. So I'm right around 23 or 24 PSI here. I'm right around the same here on my column, so these should be equal. My gauge over here on this is reading about 28, 27. So there's a little bit of pressure buildup from the start, but then by the time it gets to the tank, now we're only seeing about 28 PSI. So we're not having a whole lot of pressure in this system. Should be very low pressure operation. That's why when we first started our pressure test, I only did around 60 PSI. Because as you can see, we're not even over 30. We didn't even go over half of what we tested. So we wait for the evaporation to happen. And as it gets towards the end, we want to monitor our pressure because we want to leave a little bit of solvent in here if we're going to open this up and pour out and extract. So we'll watch our gauge and make sure it stops around 5, 10 PSI, and that should leave us with some residual butane inside our evaporator, which we can use to finally transfer or take it out of the vessel however we want. Now if I go back to my tank, I should be looking at this for how much butane we've recovered. Since we started with 10 pounds, I'm looking at here for the final amount that we have remaining. So as it's recovering, we're going back towards zero. So we're at about 6.5 pounds of butane left. And so that tells me that there's butane here in this vessel, which I do still see. And there's also maybe some butane still left in our material column, which I also am sure of it. Because I still see it flooding in right now. Really nice evaporation going on in there. Now I noticed that the pump is running a little fast, so I'm going to slow it down. I can regulate that with this pressure regulator here. And you want it to stroke about one stroke per cycle. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. So that's about what you want. Any faster than that, it's really kind of working the pump a little too hard. 1 stroke per second is about what you want. Down to 5.5 pounds left. So you guys can see the evaporation rate happening, right? Really nice evaporation. It's not slow, it's actually quite rapid. And you can see that residual solvent still dripping in from the column, which the material has trapped some of that solvent inside of it. And so you can see it's just dripping some of the residual solvent out of that column. And I'm sure that we didn't get all of the solvent out immediately. It probably equalized, and so the pump has just helped pulling it through. All right, so now that we have our Dry ice, we're gonna top it up because as this process goes, we're gonna lose dry ice. It's gonna evaporate because of the heat. That's what we're doing, we're exchanging heat. So we're gonna add some more dry ice to the top here. Just gonna leave that off to the side in case we need to add any more as this goes on. I don't think we will. We're getting down on our solvent here. We're getting close to finish, I'm sure. Yeah, so I'm gonna stop this for a second. Let me get your phone. I'm gonna show you guys what we got in here. So these are the hop oils. As we collected them, you can see there's some residual solvents evaporating. And this is a multitude of runs, so it's not the only run we've done. And you can see the hop oils there. There you go. All right. So, there's still a little solvent. I think it's trapped in this column, so I'm actually going to use some nitrogen. So I have a regulator set up over here with some nitrogen. And I'm going to pass it up to our column up here. Let's hear it. Turn up some nitrogen here. Just a couple PSI, and I'm going to use that to try and push out any remaining solvent that might be trapped here. Just some more. Gotta open the bottle. Yeah, I know, I wish I had a GoPro head cam, that'd be nice, huh? That's the next step we'll have to get. Okay. So as I'm doing that, I'm seeing now solvent flowing out just a little bit, not a whole lot. Okay, so that pushed any of the residual little bit of gas in here. Not a whole lot, just a little bit. And now I'm gonna have a little bit of nitrogen in my bottle, in my recovery tank, so I'm gonna need to bleed that off after the extraction process, and I'll do that later. We'll let this go. That's been pretty much the entire extraction. We've pretty much gone through safety setup. We've gone through the entire process of washing the material. We've also gone through the process of recovery and evaporation back to our solvent tank. Talked about the heat exchanger, safety of course, safety glasses and all that. So stay tuned and we'll see you then.